So we're still working on free response number 1. We're on part D, and it reads, region R is a solid. Is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is an equilateral triangle. Write, but do not evaluate, an expression involving one or more integrals that gives the volume of the solid. So we're just going to have to write an equation, basically, for what we did for C. And so we go to the drawing board, and again, we're going to do our little model. Z-axis, y-axis, and x-axis, and our figure looks something like this, and we are doing equilateral triangles, so perpendicular to the x-axis still, and it ends up looking something like this. All sides are equal, and so we have to come up with an equation to find the volume of this cross-section, and the equation that I've decided to use is cubed root of 3, square root of 3, 4, from integral from a to b, top minus bottom, squared dx. And so again, we're just going to have to plug in our values, and since we have 2 tops and 2 bottoms, we're just going to have to find the volume of each and then add them together. And so we're going to do cubed root of 3, 4, a, which in this case is 1, to b. In this case it's 3.69344414, top ln x minus bottom 0, squared, of course it has to be squared, dx, plus square root of 3 over 4 from, again, the intersection, which is 3.69344414, to 5, which is where the figure ends, top, which is 5 minus x minus 0 squared dx. And since we only had to write it out, that is our answer.